Well, hello again, everybody. Well, I've done what I said I was going to do. I've soaked this in acetone, just the bottom of the board, and scrubbed it with my wife's toothbrush for a while. And yeah, I think I've got a lot of the conformal coating off it, but I was a little bit worried about the acetone maybe getting into the transformer, and I don't know if it would have touched the lacquer on the enamel wiring on the transformer, but yeah, I didn't really want to submerge it. But there's still quite a lot of conformal coating stuck inside the holes where the resistors go through. So I'm just seeing if I can clean a little bit of that out first. And I was just had another look through my junk pile, and I found some resistors of a similar size. I mean, I don't know if they're exactly the same wattage. I don't know what age these are, but they certainly look similar, and they are 10 ohms. I think what I might just do though, because I always get resistor colour codes wrong, not because I don't know what the codes are, but I'm just not always very good at trying to differentiate what the colours are. So I think that I will, I'll just double check, we'll make sure it is 10 ohms, which I'm sure it will be. Brown, black, black. Is it 10 ohms? Yeah, 10.6, that's near enough. Okay, so I'm going to go ahead and I'm going to replace those 10 ohm resistors with some new ones, if I can get them through the conformal coating. Yep, that one's gone in all right. They're actually not particularly a high wattage. I think they're only meant to be about 0.5 watts, and I reckon these are probably 0.5 watts or more. I actually did order some from RS Components last night, but I wanted to kind of crack on with this today, so I think we'll just use these. I will check them though afterwards, just to see if they do run particularly hot, and if they are running hot, we'll replace them. Now there was one more 10 ohm resistor there, which we have to remove. It's not worth plugging the desoldering tool in, let's have a go doing it old schooly. Perfectamundo. I think those resistors must be quite old components, because the solder didn't particularly want to take to the legs of them. Ah, spaghetti monster! I'm also just wondering how high up they were soldered in. Right, kind of something like that. Just realised I didn't actually check the transistors. It was a friend Andy who this belongs to. He actually bought the transistors, and I would have been just as happy to have bought them for him. I said what I actually asked him to do. I said let me have it, and then I'll don't worry about the transistors, because I will just do on RS and I'll buy whatever I need. But he went ahead and bought it, so that's no problem. I was just looking for a bigger pair of pliers, because they did seem to be struggling a little bit. The ones I was using, they were bending the ends of them. That might be a fairer representation of what I was actually going for. I suspect it's going to be a fight to get this back together, and I'm going to try and leave it out of its box until we know it's functioning. Now I'm hoping this is going to be a relatively simple repair, in that if we just get these transistors replaced that have obviously blown up, I'm kind of hoping that will be enough to get this up and running. But there could, of course, be there could be many other things wrong with this as well. I guess we're just going to have to try it. Now, apparently somewhere on here there was a simple fuse which I haven't actually found yet. I think it looked a little bit like a diode, but it's actually a 15 amp fuse. Just a little like single in. Looks like a well, again, it looks like a diode, but it was actually a 15 amp fuse, and my friend Andy had already pulled that out. I think. Just looking for where it actually went. Well, you know what? I'm pretty sure that fuse went there, but it looks as though somebody, in their wisdom, has just soldered it, put a solder bridge across it. It's a little bit hard to tell because the component's actually missing, but just next to this big red wire, which is the main incoming supply, I think that there should have been a fuse installed there, and I'm wondering whether or not it was my friend Andy who linked that out just to try it, or if well, yeah, I'm just wondering why I can't see the pads exposed. All I'm seeing is blobs of solder. So I think that somebody has bridged that fuse out with a big thing of solder in the past, which is not good news, because who knows what damage has been done. There's a lot of solder on here, so I think what we will do is we'll remove some of that. But what I think somebody's done is, I think they've just linked it across with a piece of wire, and that's not good news, because if if this has been plugged in wrong, it wouldn't have blown the fuse, because there's no fuse there. We've just got a piece of wire. It's a little bit hard to tell what I'm seeing. The surface of the board is quite shiny, and it's hard to see whether I'm looking at solder here, bright shiny solder, or if I'm just looking at a reflection from a solder pad. I guess I'm just going to have to suck some more of this solder off so I can try and expose where the pad was. Yeah, I'm pretty sure there's just a big there's a big link bar in there. Can you see that? Can you see that? Hopefully you can. There's just a bar been soldered across, like the leg of a component. So that is that's worrying. That. Okay, let's try and get that bar off. So basically, that's the that was acting as the fuse, which is just a lump of metal. So I'm going to have to ring my friend Andy and find out if he bought it like this, or if he did maybe a temporary repair to try and get him home from somewhere. If he did it, he's in for a spanking. Bad man. I'm just doing what you've seen me do 100 times before. I'm just running some new solder on here because it's easier to suck new solder off than it is old solder off. I don't know if it's true, but I once read some article, again I think it was an article by Pace or somebody, and they were saying that basically old solder goes hard. The melting temperature of old solder increases because actually copper is dissolvable in tin. So basically what happens is you end up with a copper tin alloy with a higher melting point than the actual original solder. So if you actually run some new solder on it, you actually wash that alloy away, that copper tin alloy, and it reduces the melting point of the solder and makes it easy to remove. Oh, that's the story I heard anyway. So I think I said it's a little bit hard just to try and figure out what I'm actually looking at. So hopefully you can see now, I've cleaned that up a little bit, and can you see two pads there, two holes in the pads? That's where the original inline fuse would have gone, and that inline fuse was missing, and it had actually just been shorted out with something like the leg off a resistor. So it's very worrying, that, because who knows what other damage has been done. Basically every chip and this has been plugged in backwards, and but every IC and every chip on here could be blown up, and that's going to make for a much bigger repair, and maybe, I'm not going to say an uneconomical repair, because looking at it, most of the transistors and stuff on here are pretty simple, but everything's so well stuck down with conformal coating. It's just going to be a horrible job to try and get the coating off, and then get the coating off and then get these other components off. I'm wittering on about this fuse a lot, aren't I? But everybody who repairs stuff in about electronics, we've all been there, haven't we? We've all found the signs of the old artful bodger who's who's been in and done something like this, and fuses are there for a reason, and the fuse has gone, so let's put a nail in it, and it changes the repair from, it changes the equipment from something that's readily repairable to, well, in many cases just an impossibility, which it could be avoided. Well, maybe though, somebody was stuck at the side of the road and trying to figure out why the ignition wouldn't work, and it was, well, let's just try it, maybe get it going and get myself home. I don't know. I've just found a little fuse holder, PCB mounted one, but it'll do. Again, it'll do for our test purposes. What I'd do if I hadn't just made a cock of soldering it on. Okay, let's put a fuse in. I think These are normally fused at 15 amps, so I believe. But I don't know if we've got a 15 amp in that particular size. Maybe go with something a bit lower. Okay, here's a 10 amp fuse. That's got to be worth a try, hasn't it? Doesn't feel very positive in there, but I guess it'll do. Right, let's have a quick tidy up and we'll put some power on it, and depending on whether or not it just instantly explodes or does something, that'll determine what I do next, I think. We'll just also keep I haven't got a heat sink on here, but I'm kind of hoping that if it's not doing lots of discharging and things, that it's not going to instantly heat up and destroy itself. But you never know. It'll be a laugh, won't it? So I'm going to tidy up. Back in a sec. Yeah, I think I may have wrongly said in the last video that this orange and it's an orange and black wire went to the points and the distributor, but I've just been downloading the instructions, and it says that the orange and the ground return wire, the orange and the black, these go to the positive side of the coil, and the black to the neutral. So these go onto here, and they've got different crimps on, so I better just put some new ends on there. This particular coil as well, it's a special high-powered coil unit, so it's a bit different than the one that you had in your Morris Minor, although it may look the same. I think the main difference is it's just got a lower resistance of winding in it, and it draws, typically more current. So if you want to use these in a normal car application, I believe you can do it at a pinch, but you've got to install rather, well, I'm going to say large, I don't know how large it is, you've got to install a ballast resistor. And I remember back in the day, I mean, I don't know if it was common on British cars, but I'm not sure, I can't remember, it's been a while since I've played with cars. But certainly the American trucks, what they have on them is most of the times the coil packs run with a ballast coil on, or basically they do on some of the Chevys. And what happens is when you actually kick the starter motor in, there's a pair of contacts which short out the ballast resistor feeding the coil. So it means that you get the full 12 volts across the coil, whereas normally you get the current, well, it'll be a reduced voltage because of this ballast resistor. Anyway, this doesn't use a ballast resistor, so I don't know what I'm waffling on about. Well, I think it came up, I just mentioned it because we were playing with, I was playing with an American truck last week when we put an engine in, and it's been rewired over the years, and when we wired in this aftermarket starter motor, it had this extra pair of contacts on it, and initially we just weren't dead sure what to do with them, and I was talking to my friend Andy about it, and apparently he'd been having trouble with his starter motor on one of his American cars, and he'd looked into it a bit, and it turns out that's what the extra pair of contacts was. It was for basically that car would have originally, well, I say car, American pickup truck, it would have originally had this ballast on there. Well, I think we're about ready to give it a try. But until next time, I think that'll do. Bye bye for now.